How are you, my friends? This is Calculus 1 solved questions. In this video, I'm presenting some questions using Rolle's theorem and mean value theorem, and this is part 2. Please, you can go and check part 1. Question number 1, we have the function given f of x is equal x cubed minus 4x is defined on the interval, closed interval 0 to 3. Find a value of c that satisfies the conclusion of mean value theorem. So first we check, this is a polynomial function of degree 3. Between 0 and 3, the function is continuous on the closed interval 0 to 3 and is differentiable on the open interval 0 to 3. F of 0 is equal 0, replace 0 in the function. F of 3, replace 3 in the function, we will get 15. So let's find the derivative. F prime of x will be 3x squared minus 4. And the mean value theorem says f prime of c is equal f of b minus f of a divided by b minus a. So f prime at c will be 3c squared minus 4 is equal to 15 minus 0. This is the difference in the images. And b minus a will be 3 minus 0. Simplify, we get 3c squared is equal to 9. Because this is 15 over 3, 5. Take 4 on the other side. Divide by 3c squared is equal to 3. Take the square root of both sides. C will be plus or minus square root of 3. Now, square root of 3 is almost 1.7. So it is included between 0 and 3. And the other one, we cannot take minus square root of 3. So the conclusion here, the line through the points, see this line here, through the points 0, 0, and 3, 15 is parallel to the tangent line to the curve at the point square root of 3, this is C here, f of square root of 3. We replace square root of 3 in the function itself here. When you simplify it, you will get also minus square root of 3. So that is the point here, square root of 3 minus square root of 3. Question number 2 says the function x cubed minus 8x minus 5 is defined on the closed interval 1 to 4. Same idea, find the value of c that satisfies the conclusion of the mean value theorem. We check that f is continuous. It's a polynomial function also on the closed interval 1 to 4. F is differentiable on the open interval 1 to 4. We find f of 1, replace 1 here in the function. It will be minus 12, and replace 4 in the function, it will be 27. Find the derivative, 3x squared minus 8. Now, the mean value theorem states that f prime of at c is equal to f of b minus f of a divided by b minus a. We find here 3c squared minus 8 is equal to 27 minus 12. Divided by b minus a, which is 4 minus 1. Simplify the whole equation. Multiply by 3 on both sides, you get 9c squared minus 24 is equal to 39. So 9c squared is equal to 63. Divide by 9, c squared is equal to 7, and c will be plus or minus square root of 7. Square root of 7 is approximately 2.6. So only square root of 7 is included in the given interval 1 to 4, minus square root of 7 is rejected. So the conclusion now, the line through the points 1 minus 12 and the other point 4, 27 is parallel to the tangent line at square root of 7. This is c, and this is f of c. If you replace square root of 7 in the function itself here, after you simplify that, you will get minus square root of 7 minus 5. That's the y value, and this is the x value. Question number 3 says, find the number of points that satisfy the conclusion of Rolle's theorem for the function f of x is equal to x to the power 4 minus 4x squared plus 3 on the interval minus 1 to 1. Now, here in the Rolle's theorem, we have to check f of 1. F of 1, replace 1 in the function, we get 0. F of minus 1 also, we replace minus 1 in the function, we get also 0. F is continuous on the closed interval and differentiable on the open interval. Also, the images is the same. F of 1 is equal f of minus 1 equals to 0. We have shown that here. So all the conditions of Rolle's theorem are satisfied. Let's look at the derivative. F prime of x will be 4x cubed minus 8x. So f prime of c is equal to 0. So 4c cubed from here minus 8c is equal to 0. Take 4c as a common factor. 4c in the bracket inside, we get c squared minus 2. We can factor this more. So it will be 4c, c minus square root of 2, c plus square root of 2. So we have three values for c. But we have to check the interval, given interval minus 1 to 1. The only acceptable c is c equals 0, because square root of 2 and minus square root of 2 are outside the interval. Question number 4. Find the values of c, maybe one or more, satisfying the conclusion of Rolle's theorem for the function f of x is equal to square root of x times 1 minus x on the interval 0 to 1. So now this is the given function. We can multiply inside. So we get the function is equal to square root of x minus x squared, so that we can find the derivative easily. So f is continuous on 0 to 1 closed interval. F is differentiable on the open interval 0 to 1. Also, we check the image. F of 0 is equal to 0. F of 1 is equal to 1 if we replace 0 and 1 in the function. So all the conditions of Rolle's theorem are satisfied. Let's find the derivative. Since we have a square root of a function, so it will be the derivative of the inside function divided by 2 times the square root of x minus x squared. The derivative here will be 1 minus 2x over 2 times this. F prime at c is equal to 0. So if we put all this is equal to 0, we take the numerator is equal to 0. So 1 minus 2c is equal to 0. C is equal to half. Yes, we can check here that half is between 0 and 1. So the only c value is c equals half. Now, suppose question number 5, suppose that f prime of x between 3 and 5 given for all values of x, and suppose f of 8 minus f of 2 is greater than or equal to a, less than or equal to b. Let's find the value of b minus a. Maybe this is a little tricky question. You have to understand that you have to use the mean value theorem. F prime of c is equal to f of b minus f of a divided by b minus a on the interval 2 to 8. So b here is 8 and a is 2. So from this mean value theorem equation, we can write f prime of x is equal to f of 8 minus f of 2 divided by 8 minus 2. Given now the derivative itself between 3 and 5. So we have this inequality here, the compound inequality. So we can replace f prime in the middle here, f of 8 minus f of 2 divided by 8 minus 2. Now we can simplify 8 minus 2. We don't know what is f of 8 and what is f of 2, so we leave it. 8 minus 2 is 6, so we can multiply, that's a constant. So multiply the 3 sides here by 6, the whole inequality. So it will be 18 less than or equal to f of 8 minus f of 2 less than or equal to 30. Now directly we can say a is this one here, 18, and b is 30. What do we need in this question? B minus a, 30 minus 18, the answer will be 12. Now, for more questions on Rolle's theorem and mean value theorem, please, you can see lecture number 16. And also there is part 1. And for more questions on general in Calculus 1, please, you can see Calculus 1 solve questions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.